So these are the questions that I want to go through. What we talked about last time, we talked about lines, right? Equations of lines, right? We talked about the slope of a line and how to find that. y2 minus y1 over x2 minus x1. And we talked about the three different kinds of lines, y equals mx plus b. We talked about the point slope formula, y minus y1 equals mx minus x1. Point slope form. And these are going to be the two that we really mainly use. These two, mainly. And then, of course, our slope. Equation for slope. So looking at number 3, really just a quick review of lines. This says to sketch the lines. Sketch the lines through the point with the slope. Through the points. Through the point with the slope. So my point in number 3 was 2, 3. And the slopes they gave were a slope of 0, a slope of 1, a slope of 2, and a slope of -3. So I just really wanted you to sketch, right? Again, let's draw a coordinate axis. Draw some coordinates here. 2, 3. So I'm going to draw my lines here. 2, 3 is right here. There's my point, 2, 3. And I'm going to do this in different colors. So a line with a slope of 0 through this point. Rise over run is 0 over anything. So a slope of 0, we talked about what this slope is. This is a straight horizontal line. M equals 0. So that's our first line, right? Just slope of 0 through the line. Slope of 1, of course that means rise 1, run 1, right? 1 over 1 goes right here. And so, or I can go backwards, down 1, backwards 1 right here. And this is the line through m equals 1. Right? Slope of 1. Try to draw this a little better. Slope of 1. Slope of 2. Again, that means up 2 over 1, so you're right here. Or down 2, backwards 1, you're here. Oops, here rather. And so this line goes like this. M equals 2. And slope of -3, right? -3, that means down 3 over 1, always over 1, down 3, 1, 2, 3 over 1, 2 right there. Or up 3, backwards 1, 2 right there. This is the line of a slope is -3. So that's the kind of thing I'm looking for, right? Your main point is right here at 2, 3. 2, 3. And all the lines go through, well, you know, again, my drawing is not perfect, but all the lines go through that point, different slopes, just sketch it out, what it looks like. Okay? All right. That was 3. I'm going to say here 27. And again, if there's a particular question you want, type that in the chat. I just want to make sure we're getting through all these clarifying things. 27. 30. Okay. 32. Let me add 30 to this list. The 30 was even. What are you talking about? Trying to confuse me. 31. Okay, maybe 31. That's like all these questions. Anyway, we'll see what we have time for. We'll see what we have time for. All right, 27. I'm going to do that one next. 27. So this one said to find the general form of the equation, or find a equation that passes through the given point and has the slope. So find the equation through point with a certain slope. And so 27 says the point is 2, -3, and it says my slope is -1/2. Oh shoot, why did I close the book? Don't do that. Come back, book. So there's my point and my slope. I want to make an equation. It says the general form, but general just means, I mean, to me, I'm just going to say any equation is fine. So we have a point and we have a slope. So we're going to write the equation. We have a point and a slope. I'm going to use point-slope form. Y minus y1 equals mx minus x1. Slope and point. So I'm going to just plug these in, right? My point here is x1 and y1. So I'm going to plug those into here and here. And my slope is 1/2, and that's going to go here. -1/2. So just plug them in. Y minus -3 is -1/2 x minus 2. Creating your equation from a point and a slope. And that's what we got. Like I said, this is an equation. That satisfies the necessary conditions of being an equation. It's got all the pieces plugged in. I have an x and a y as the only variables, and everything else is numbers. Everything else describes the equation. I can, however, rearrange this and be a little bit more clear. And it's a really good idea to make sure you simplify and arrange this in a way that's sort of the most helpful for you. So I'm going to make this into y equals mx plus b, because that's most of the time the way the type of equation that's the most helpful. So simplifying, minus minus, right? Minus minus, these become plus plus, right? So this is y plus 3 equals, distribute this 1/2, distribute. So I got -1/2 x, -1/2 times -2 is positive, negative times a negative, 1/2 times 2 is 1. So I've got y plus 3 equals -1/2 x plus 1, distribute that 1/2. And then a -3 on both sides to simplify. I'm going to get y equals -1/2 x minus 2. And there's my equation. Okay. Now it said standard form. What was it? General form. General form. General form of the equation, if you want to be really precise, is ax plus by equals c. We call that standard form. This is sort of also called general form. So maybe some of you put it into this style of equation. And the rule here is no fractions. The rule for the general form equation is there are no fractions. Where did the -2 go when I distributed the 1/2? So multiplying, okay, let me do a little aside here. So multiplying -1/2 times 2, multiplied by 2. 2 is 2 over 1, right? -2. -2, here's -2. -2 is really -2 over 1. This -2 is a fraction, right? So -1/2 times -2 over 1. multiplying this. When you multiply fractions, the tops multiply and the bottoms multiply. So this becomes -1 times -2 is +2. 2 times 1 is 2. 2 over 2 then becomes a 1. So that's where this 1 came from, right? This +1 came from right there. Okay? So multiplying these fractions, right? -1/2 times 2. 2 is like 2 over 1. Became a 1. All right, but back to general form. So if I want to make this into general form, I need to put the x's and y's together. And I need to make no fractions. So how can I cancel a fraction, this -1/2? I want to cancel this fraction. To cancel a fraction, we have to multiply by the denominator. This 2 on the bottom. Whoa. Too big. This 2. Stop it. This 2 on the bottom. 2 on the bottom. I need to cancel that 2. So what I'm going to do is multiply the entire equation by 2. I want to go back to the bigger one. Multiply the entire equation by 2. That's multiplying every single piece by 2. And what that's going to do is cancel this 2 on the bottom. So this 2 times the y is 2y. 2 times y, right? 2 times the -1/2, well, we just did that, right? That's going to be -1x. And 2 times -2 is going to be -4. And now you see my 2 on the bottom of the fraction canceled, and I have no fractions left. Now I want to put the x and y together. Add the 1x on both sides. Move this x over here, right? Just like regular algebra. Move your pieces, right? Cancel this 1x, move it over to this side. So I'm going to get 1x plus 2y equals -4. Or just x plus 2y equals -4. And that's also an answer, totally fine. Totally fine, totally fine, totally fine. These three different interpretations of the same equation are all completely fine as an answer. Okay? Questions about this? So simplify your answer, simplify your equation. Sometimes you can do it in lots of different ways. If you're given a point and a slope, it's easy to start with point slope. You can then rearrange that to y equals mx plus b, or simplify. And even you could rearrange it to standard form if you wanted as well. Let me try another. Which one did I do? Which one did I say? 29. 29 or 31? 29 or 31? Let me see. Let's do 29. So, 29 says, same idea, find an equation. Through the point 6, -1, and the slope, it says, is undefined. Okay. Slope is undefined. Someone tell me what kind of line this slope means. Someone tell me what kind of line, what equation. Remember, there were 5 equations of a line. Which equation had an undefined slope? Destiny, yes. Vertical lines, exactly. Vertical lines have an undefined slope. That means your slope is, your line is straight up and down. And the equation of every vertical line is always x equals some number. Call it c, some constant. The equation of vertical lines is always hold on. Always x equals some constant. So how do I know what the equation is if I'm just given this point? It's always, remember, my equation is always x. So x equals something. Well, what is x supposed to equal? Looking at this equation, look at this point rather, this is my x. My equation has to go through this point. It's got to go through this 6 comma negative 1. So if that's x, that's going to be my equation. That's what x is. X is 6. And that's the equation of your answer. When you're given an undefined slope, when your equation is x equals or y equals a constant number, this number comes from the point. Comes from the point. It comes from whatever point you're crossing. So if I'm crossing 6 comma 1, my answer is x equals equation, x equals 6. 6 is the answer. The same thing with 31. My equation is negative 1, my point rather is negative 1/2 comma 2/3, 3/2 rather, negative 1/2 comma 3/2. My slope in this case is 0. What kind of lines, someone tell me, what kind of lines have a slope of 0? What kind of lines have a slope of 0? Someone tell me. Edward, thank you. Horizontal lines, exactly. Horizontal lines have a slope of 0. Perfect, right? So these equations are always y equals a number. Y equals. Horizontal lines, slope of 0, always y equals. So if my equation, my point is negative 1/2 comma 3/2, here's my y. The y comes from the point. My equation is y equals 3/2. Done. And so that's where these lines come from, right? Horizontal lines are y equals, well, there's your y in the point. So y equals 3/2, that's your equation. It's just going to be the same with vertical, horizontal. These two are really easy. But you got to remember it. You got to remember the rule. Undefined slope, vertical. Vertical is x equals a number. What number? The point. 0 slope is a horizontal line. Horizontal is y equals. Y equals a number. What number? In the point. Okay. All right, there were some other ones people asked for. 33, 37, 45. 33, 37, 45. So let's see. 33, 37, 45. What time is it? How much time do we have? We're out of here in 30 minutes. Okay, that should be good. So let's do 33, 7, and 45. Let me do 33. So here in 33, it wants you to write the slope-intercept form of the equation that passes through the points. So we want a slope-intercept. We want points are 5, comma, negative 1, negative 5, comma, 5, negative 5, comma, 5. So this is our point, and I want an equation through this point, and I want a y equals mx plus b. So So I'm going to write the equation of the line that goes through these points. First thing I need is my slope. First thing I need is my slope. So my slope is m. Let's find that first. y2 minus y1 over x2 minus x1. And so here's my y2 and here's y1. Do x's in green. x2 and x1. So I'm going to say this is 5 minus negative 1. And my y is 5 minus negative 1 over negative 5 minus 5. Negative 5 minus 5. So that's going to be, this is minus minus, so that's a plus here. So that's 6 over negative 10. Whoop. Negative 10. That's my slope. Now I want to simplify. You always want to make your slope smaller. So 6 over negative 10, that actually becomes, I can divide this by 2. Divide by 2. 2. So it becomes a 3 over, divide by 2, it becomes a negative 5. So there's my slope m. Right, using those 2 points, find the slope. And now I can use this slope to find my equation. Right? Now there's a couple ways to do this. I showed you a way earlier. I'm going to scroll a little bit up here, right, where we plugged in our x1, y1, right? We used this equation here and plugged in, right? Y minus y1 equals mx minus x1. We use this equation here. And we can, same thing. You can plug it in, right? Plug in your x1, y1. But let's say you only want to remember, let's say you only can remember, the only equation of a line you can remember is y equals mx plus b. It's the only equation of a line you can remember. You're stressed out, whatever, you only, y mx plus b. You can find it using this equation. So let me show you how to do that with just this y equals mx plus b. If we do y equals mx plus b, let's plug in our slope of 3 over negative 5. Y equals negative 3 over 5 x plus b. The thing we need to find is this b. Where does that b come from? That b comes from using a point. I shouldn't say use. I should say plug in. Plug in. Oh, goodness. What in the world? Plug in a point. You're going to plug in one of your points here, 5, negative 1, or negative 5, 5, into x and y, and then use that to find b. That's a really easy way to find this equation. You need to use the slope, and you need to use a point. So, which one do I use? Doesn't matter. I'm going to use this first one. So I'm going to plug in my x and y. Y is negative 1. So negative 1 equals negative 3 over 5 times my x is 5 plus b. Doesn't matter which point I use, I just chose that one. It'll work the same for either one. Plugged in my y of negative 1, plugged in my x of 5, and I have to solve for b. Multiply these fractions. Negative 3 over 5 times 5. 5 is actually 5 over 1. So if I multiply these fractions together, I get negative 15 over 5, and divide those. Negative 15 over 5 becomes negative 3. Another way you can think about these multiplying fractions is that this 5 bottom can cancel this 5 on the top. These 5s can cancel out. And so I'm left with just negative 3. So I've got negative 1 equals negative 3 plus b. Is there a question? No. Simplify this. I want to solve for b, so I'm going to add 3 to both sides. Add 3 to both sides. b is equal to negative 1 plus 3 is 2. There's my b. And now I can use this and the slope to get my final answer. Y equals negative 3 over 5, my slope. X, my b, plus 2. And there's my answer. Whoops, daisy, what's going on here? Here. There's your equation of this. Yeah, so Christopher, there's a question about this 5. Where does 5 over 1 come from? So the 5 is what x was, right? X was 5. But every single number is automatically, like every regular number, every integer number is automatically a fraction over 1. So because I had to multiply this 5 here, by, can I do a pointer? Because, hold on, laser pointer. Because I had to multiply this 5, right? This 5 comes from right here, right? This 5 comes from here. Because I had to multiply this 5 by this fraction, I made this 5 into a fraction. I made it over 1, 5 over 1. Because this 5 is a fraction over 1. And then I can cancel my 5s. Or if I multiplied, right, 3 times 5 is 15. 5 times 1 is 5. 15 over 5 becomes 3, or negative 3, right? Or if I cancel these two 5s here, the negative 3 is all that's left over, right? Negative 3 over 1, which is just negative 3, right? Negative 3 divided by 1 is negative 3. And that becomes my number here. And then I add it to both sides, cancel it from here. Negative 1 plus 3 is 2. And that b becomes the b in my answer right here, right? And my slope comes here. So this whole thing, right, comes to your answer. You found the slope by using the slope formula. You plugged it in, plugged in a point, find the b by using a point. I chose this one, you could choose this one, doesn't matter. But you find the b by using a point, plugging it into x and y, right? Here's your y, here's your x, plug in the point, find the b, plug it in to make your equation. Okay? Interesting. So that was 33. Let's try this again. On, what did I say, 37? 37. Oh, 37. "37 has fractions." Oh God. Oh God, mister. Why have you given me a problem with fractions? Do you hate us that much? No. I care about you that much. I care about you that much. Well, I care so much about you, I give you a problem with fractions. That's how much I care. If I didn't care, oh, they don't need to know fractions. Oh, what's happening? Stop it. Hey. There. All right, we got to do the same thing. Y equals mx plus b. First, we got to find our m. Slope is rise over run, right? Y2 minus y1. So I'm going to do my fraction. I got to do my fraction solving, my equation, right? Find this slope. So y2 minus y1. So I'm going to do 5 over 4 minus 1/2. That's the top. Bottom, x2 minus x1. I've got 1/2 minus 2. And then you cry. Right? Isn't that the answer? Then there's just tears. That's what's next. No! No. There's no crying in baseball. Sorry. It's a movie that you wouldn't understand. No, it's there's no crying. It's fine. We could just deal with it. We gotta just deal with it, and it's fine. We have to subtract these fractions. Yes, deal with it. So how do we cancel? How do we subtract fractions? Let's go back to our what is it, like 7th grade when we had a lot of fractions. When I subtract fractions or add fractions, what must be the same? Thank you, Destiny. Denominators, yes, actually, absolutely, yes, Chris, for the denominator. The denominator, the bottom of the fraction's got to be the same. I have a 4. Where's my pen? I got a 4 here. I got a 2 here. They're not the same. I want to make them the same. I'm going to turn the 2 into a 4 by multiplying. The only way you can change a fraction is by multiplying it or dividing it, whatever. But multiply this 2 by 2 times 2 and do the same to the top times 2. I'm gonna make this into 5 over 4 minus 2 over 4. Great. Now I can subtract. That becomes 5, 4, 3. 3 over 4 on the top. What about the bottom here? What about the bottom? 1/2 minus 2. 2. This 2 is not a fraction yet, but I need to make it a fraction. What number goes in the bottom, everybody? Over 1. So now I need to make this a 1. I need to make this 1, automatic 1. I need to make this 1 into a 2, so I multiply by 2 times 2 on the bottom here times 2 on the top here. I make this 1/2 minus 4 over 2, and I subtract. Now I can subtract. 1 minus 4 is negative 3 over 2. Okay, we're getting there. We're getting there. 3 over 4 over negative 3 over 2. And now I've got fractions on fractions. Fractions on fractions. Nobody likes fractions on fractions. I want to make this not a fraction. We have to deal with it. We have to deal with it. What can we do to this situation? Well, again, let's remember back to 7th grade how we learned a little trick about fractions. If something is on the denominator, what is it? Keep, change, flip. Keep, change, flip. You're going to take the denominator, the bottom part, you're going to flip it around and multiply by the top of the fraction. Flip and multiply. Take the bottom, flip, and multiply. So that's going to become 3 over 4 times 2 over negative 3. Keep, change, flip. Flip and multiply. And multiplication is a lot easier. In fact, so easy, this one. If I multiply the top numbers, 3 times 2, that's going to be a 6. 6 on the top. Multiply the bottom numbers, 4 times negative 3 is negative 12 on the bottom. And what does that become? Can I make this simpler? Yeah, divide by 2. Divide by 6, in fact. More than 2. I can divide the whole thing by 6. And I'm going to get 1 over negative 2. These can simplify, right? And there's my slope. Negative 1/2. Now, this took us a while because we did it slowly. But this kind of thing, this kind of stuff that we just did together, you're going to get really good at. You're going to move fast with this stuff. Fractions, what do? Make the add them, make the bottoms the same. Multiply, okay, make them the same, and cancel the tops. Fraction over fraction, fraction over fraction, take the bottom. Flip and multiply. Flip and multiply, right? Multiplying fractions, you can cancel things or simplify. Right? I could have done the canceling of the fraction back here. Back here, when I was multiplying, notice some things that I can cancel on the tops and bottoms already. This 3 and that 3 can already reduce. I can cancel this 3 and cancel this 3. This 2 and this 4, I can reduce those as if they were one fraction, because really this is all just one fraction, one big fraction. 2 can become a 1, 4 can become a 2. Right? So I got a negative 2 on the bottom and a positive 1 on the top, and that's where my fraction comes from. So you will get more familiar with these fraction, multiplication, division, etc., etc. You'll become more adept at it. But negative 1/2, that's our slope. We got to still find our equation. Let's finish this up. Y equals negative 1/2 x plus b. Making our equation. All right, everyone who is paying attention, where does b come? How do I get b? Where does b come from? The points. Thank you. Yes, I use one of these 2 points and I plug them in to get this b. Which one do I want to use? Let's go with the one that has less fractions. How about that? Fewer fractions? I think that's a good idea. Let's go with this one here and see what we can do. So I'm going to plug to this x and y into my equation. I'm going to plug in x and y. So I'm going to do, this is going to be 1/2. I plug this point in. 1/2 equals negative 1/2 times my x is 2 plus b. Okay. Got to simplify. Multiply these 2 things together. Negative 1/2 times 2. I got to make this 2 a fraction. Make it 2 over 1. Multiply the tops and bottoms, right? Negative 1 times 2 is going to be negative 2 on the top. 2 times 1 is 2 on the bottom. 2 over negative 2 becomes negative 1, or I can cancel these 2's. Either way, it becomes negative 1. So we've got 1/2 equals negative 1. Negative 1, oh God. Negative 1 plus b. Add 1 to both sides. Add 1 to both sides to simplify. Oh, goodness gracious. Add 1 to both sides. And 1/2 plus 1. Uh-oh. Again, we've got fractions. 1/2 plus 1. I make this 1 a 1 over 1. Multiply it by 2, multiply it by 2, make it into, goodness gracious, make it into, multiply this by 2, make it into 1/2 plus 2 over 2, which is 3 over 2. And that's b. So there's my b, here's my b, here's my m, put them together, y equals negative 1/2 x plus 3 over 2. There is your equation. Oopsies. There is your equation. For 37. Feeling okay, everybody? Fractions! No! Why, God, why? Yes, yes. Deal with it. Deal with the... You're in pre-calculus now. Fractions are going to be part of your life. We're going to actually learn more numbers than just fractions. There's other numbers that you don't even know about yet. New numbers that we're going to learn about that you have to deal with too. So, fractions are the least of your worries. These are the easy ones. Yeah. But it's okay. We'll deal with it. That's what we got to do. We just got to deal with it. You can deal with the pandemic. You can deal with fractions. Please, come on. It's fine. All right, last one. We do have 10 minutes left. I want to, more than imaginary, even more than those, Benjamin. More complicated. All right, I want to do one more. We said the last question was 45. Number 45 here. We have 10 minutes. Let me just do this last one, this word problem. Now that we have seen how to make equations, right? The word problem is exactly the same. The word problems are exactly the same, right? It's just data is given in a way that is different than just points. It talks about information. So in number 45, it talks about annual salary, right? A jeweler's salary was $28,500 in 2004 year, and then her salary was $32,900 in 2006. So we want to know, what will it be in 2008? Assuming that it follows a linear path. Assuming it's growing the same all the time. The jeweler's salary follows a linear growth pattern. So assuming that it's growing the same linear amount, what will this person's salary be in 2008? Now, there's a really easy way to solve this problem, and there's a harder way. I'm going to show you the easy way. Can anybody think of a pattern that we're seeing here that we can use to solve this? I need someone to explain. Edward Rivera, what do you mean by 2? These years are going up by they go up by the same amount every time, right? Plus 2, plus 2. Yeah, so if these are going up by the same amount every time, what does that mean about the salary, Edward? Yeah, it's going to increase by the same amount. That's what linear means. Linear means you're growing the same amount. So how much did we increase here? Let's take out our calculator. 32,900. 32,900 minus 28,500 is 4,400. So this added 4,400 to their salary in 2 years. So if they added that much in 2 years, well, in another 2 years, same amount. 4,000. So 32,900 plus 4,400 makes it so it's 37,300. 37,300. Oopsies. 100. There is your answer. Oh God. There is your answer. That wasn't so hard. We just had to recognize a pattern. Seeing this pattern here and figure out the increase. It's helpful to write it down. A harder question would be, what would they be in, let's say, 2011? Because that is an increase of 3 years, and so it's not going to be the same. And for that one, we would need an equation. Well, I guess we could kind of figure out the growth, right? Maybe we can still do that an easy way. Maybe we can still do it. Let's say I want to know what's the salary going to be in 2011. That's plus 3 years. Can anybody see how we might be able to add, like how much? How can we figure out how much to add to her salary in 3 years? Any ideas? We know that it went up this much in 2 years. How much is it going to go up in 3 years? How can we figure that out? Destiny, yes, divide what was being added each in 2 years. Yeah, if this, exactly, this 4,400 was every 2 years. Exactly, Benjamin, right? So if it's 4,400 in 2 years, that means, oh, goodness gracious. That means in 2 years, that means it was 2,200 per year. So 3 years times 3, that's going to give us 6,600. Add that much, 6,600, how much it is in 2011. 37,300 plus 6,600. 43,900. 43,900. Exactly. Right? We can figure out these growth rates, and this number here, this number that you figured out, the salary per year, we call that a slope. That's exactly what a slope is. Slope is just an amount of growth over a certain time. We took the y value, right? We took the growth value. This is like our y values, and the year is like our x values. And so we took our y, our change in y, divided by the change in x. Right? The change in y was 4,400. The change in x was 2 years. And that's how slope works, right? This definition. And now, and this is pre-calculus. We're gonna end here, but let me just say this one last thing. This is what pre-calculus starts to paint a picture for us about the connections between the numbers that we're using and how they can represent things in the world. Right? Slope is no longer just y2 minus y1 over x2 minus x1. It's no longer just a numbers on a page. It can then have meaning for us. It can create some kind of connection where you're talking about something growing. Slope is a rate. It's a rate of growth. All the equations we've done, you could put any of them in a word problem and they'd be exactly the same. So things grow, and you can see that the meaning behind these, right? Our salary is y, our change in salary was important, and the change in years, and we use those values in the method of using slope to figure out answers to questions we want to know. And that's pre-calculus. Seeing this, starting to see this bigger picture of connections between things. Okay? All right. Any last questions? I think we're out of time. All right, let me stop this recording here.